I'd like to introduce you to a pretty slick online app. This is located at potentialflow.com. If you just go to that homepage, it will take you right to this simulator. They call it a potential flow simulator. And what you see here is an XY coordinate system here, just a two-dimensional coordinate system. And we scroll down, we can see there's a bunch of flow elements that we can add to this coordinate system. Now they have some presets here as kind of the default tab, but I'm going to go into custom first. Now that we understand how these different potential flow elements are created and what they are, we can go in and add these specific elements to this two-dimensional space up here. So I'm just going to work through an example here. Let's give a uniform flow of 1, 0. So that's just going to be some horizontal flow. I can scroll back up. You can see that horizontal flow there. Those are the streamlines through that geometry. And by the way, over on the right-hand side, now it shows that I have a uniform flow as one of my elements. Now I'm going to come down and add a point source at, let's give this some negative offset like -2. And we'll add that to the flow. And so you can see at the location of -2, we've got a source now that's emanating flow out of it. And again, it showed up on the right-hand side as our second potential flow element. And now I'm going to add a sink at the +2 location. And in order to make a sink, I've got to make that m value, which is the magnitude, negative. Okay, so now I'm going to add that and scroll up, and I can see now I've got a source on the left-hand side, a sink on the right-hand side. And so you can see this is that ranking oval that can be created by doing that. And you can roughly see the boundary of that oval. It really depends on how these streamlines, where they're choosing to put these streamlines, of whether or not you can see those boundaries very well. Okay, so you can play around that. We could add a point vortex, for example. Let's put this at -20, just right at the center line. And now we see we get some vorticity in the flow, so it's coming from the left-hand side and gets kind of thrown down to the right-hand side. So that's actually positive circulation. Now they have the sign of gamma here, negative, in order to create positive circulation, but that's just a sign convention difference from what we've been talking about. Anyway, you can go on and add a dipole. That's another word for a doublet. We've called that a doublet. And frankly, I see doublet more in the literature than a dipole, but that's what the dipole is. And then a corner as well. There are potential flow solutions for going around a corner, and so you can add those to the flow field as well. So if you come back over here to the Add Preset tab, you can automatically add in a ranking half body, an oval, a cylinder, a rotating cylinder. It has some presets and it shows you what those are composed of. So for example, the rotating cylinder has a uniform free stream plus a dipole, which is our doublet, plus a point vortex. And so you could add that. In fact, let's just delete out on the right-hand side. I'm going to delete all these elements, and we're just going to add a rotating cylinder now. And it gives me all of these, I'll scroll up so we can see that. On the right-hand side, it shows me the 3 different components that made up the rotating cylinder, and I can actually just go in and change the values of that, and it will automatically update. So I can change that to 200, for example, and it updates live. Anyway, it's just a really slick little app to help you see how to add potential flow elements into this field and what each of these does. Now, a couple more things I want to point out. It's got an Inspect Flow tab down here. So you can enter a point and look at the pressure at that point. And right now it's got the point at 0, 0. So it's showing that the flow at 0, 0 has an infinite velocity. And anyways, but you can walk around the flow and look at the pressure or different things in the flow. And then up at the top, on the left-hand side, you see that drop down is set to stream function right now. So we're looking at the streamlines, but we could look at the velocity potential. So this is the value of phi. Remember that the velocity is the gradient of phi. So this is a scalar, the velocity potential is a scalar throughout the flow field, and it's the gradient of this scalar that tells us what the velocity field looks like. And we can also just look at the x velocity components or the y velocity components. Anyway, it's just a pretty slick little app. I hope that you take some time and play around with it. They've also got some interesting things, some other things in their menu on the top right. They've got some equations, for example, for each of these elements as kind of a review. You know, we've gone over most of these equations, but that's a general overview. And anyway, we've got a few other things that you can explore about potential flow.